So let's talk about our first quantum number, and this is going to be our principal quantum number represented by the lowercase letter n. Now, this is a very important number because this is what's going to do a really good job of setting the energy of electrons. This is basically, if we were to use the analogy of an address, this is your city, state, and zip. This is really going to specify things for you. So what are the rules for n? Well, n has to be an integer greater than or equal to 1. So you can take in values of 1, 2, 3, 4, and so forth. Go all the way up to infinity. Typically, though, we don't see n much bigger than 5 or 6. But still, these are our values for n. So the big thing n is going to dictate for us, first of all, is the number of radial nodes. And this is going to be equal to the principal quantum number minus 1. So if we have n equals 1, we have no radial nodes. What does this mean for us? Well, let's say we had a spherically symmetric atomic orbital, s orbital. And we looked at the probability of finding the electron as a function of distance away from the nucleus, r. For n equals 1, it's going to look continuous. So we don't see any break in the electron density as we move away from the nucleus. If we have n equals 2, we have 1 radial node. We're just going to arbitrarily draw it here. This will be our first radial node. And what happens is, beneath this radial node, close to the nucleus, there is some electron density, but there's not very much. Most of our electron density is actually beyond the radial nodes. And what we see is that when we put our radial node in, it actually pushes the electron density further away from the nucleus. Our nucleus is down here at 0 radius. And because we're pushing the electron further away from the nucleus, we're raising the energy. If we have n equals 3, we'll have 2 radial nodes. So this will be our second radial node. And our first part is going to look kind of the same. We're going to have another little bit, and then we're going to have electron density pushed even further away. So as we increase n, we're increasing the energy of the electron. And this is because we're pushing electrons further and further away from the nucleus by increasing the number of radial nodes. Now, this is the first big property of the principal quantum number. It's going to set the number of radial nodes, and it's going to increase the energy as we set up these nodes because we're pushing electrons further away. The second thing it's going to do is it's going to set limits on our angular momentum number L. So that'll be the next video where we talk about L. But n sets L, and it also sets the number of radial nodes.